environment. You will review the short, hopefully 15-minute or so video, and that concludes your commitments for this quarter's work, other than answering a brief question at the end of the presentation and of course submitting all of your written work and sitting for the final exam. Teach a person to fish and they will feed themselves every day. Teach a person how to make conceptual models and they will have a mildly confused understanding of the world every day. A kid. But in the last 10 weeks or so, we have been trying to compress a lot of information about how to understand the human impact on the global environment, and understanding that a lot of specific information you'll glean from a review of the reading material and from thinking about case studies. We've elected in class to look at some fairly simplified models of our understanding of humans as ecological beings, and understanding in some simple but slightly non-intuitive models about a reconceiving of what impacts mean. So we will, in a series of about 8 or 9 slides, just review some of the material that we have considered in recent weeks. One of the overarching ideas that I have been inviting you to think about over the quarter is the fact that humans, of course, are products of natural processes. One does not, of course, need to think about any non-natural forces in terms of understanding why humans are here in the first place. We're the products of the same ecological and evolutionary forces as all other species, and yet at the same time we have also been remembering that not all consequential ecological and evolutionary events occur in a slow linear fashion. And it's that contrast between kind of slow linear change and more cataclysmic disturbances that we have been using to think about the nature of some of these problems. One of the first of the conceptual models that we looked at in a variety of ways with Kate Raworth, the economist, but with a range of other thinkers, is to conceive of the world as a global ecosystem that's relatively finite, relatively bounded, I should say, in terms of material inputs. We're stuck with what we've got, more or less, but it is an energetically open system. So we can conceive of humans as, and human kind of economic matters, as being a subset of a global ecosystem, and then ask the question concerning the degree to which we are pushing up against the limits of that global ecosystem. There are those, of course, who subscribe to the notion that this is a full ecosystem, that we're very close to the limits with potentially catastrophic implications, and those who and maybe there are fewer of those in environmental circles who regard us as being some distance from those limits. We asked about environmental risk in the context of other global risks, from pandemics to nuclear holocausts and the like, asking ourselves the question whether environmental problems, climate change, biodiversity loss and the like, are comparable to the other potentially cataclysmic events that those concerned with risk analysis spend time investigating. Our conclusion, I hope, from that was that even though climate change, biodiversity loss, pollution of fresh waters, the depletion of soils and the like are of major global concern, they are also characterized by being potentially solvable problems. So in the language of Nick Bostrom and Milan Kirkovic, they don't represent existential crises. So they don't represent existential crises, but they are certainly global in scope and endurable in severity. We spend quite a bit of time during the quarter with Ian Tattersall and other writers thinking a little bit about what is it to be human from an ecological perspective, when that ecological perspective on humans can help us understand the nature of human impacts. We asked questions about what it is that make humans special, that animal that was 180,000 years or so ago extremely rare globally, to one that is almost omnipresent on the planet. And one of the ways in which we answered that question was to think about the cognitive complexity, or to use the language of Stephen Mithen, the cognitive fluidity that humans possess. So humans' capacity to use flexible behavior, culturally embedded behavior, in order to make decisions about how to reshape the world in ways that match our needs. This is the means by which we have certainly created difficulties for ourselves, but it is potentially, of course, also the way in which we resolve some of these issues. We also told the story over the course of the quarter about how humans did transition from being this relatively rare primate, this relatively rare tropical primate, to become almost global in distribution, and made use of this notion of what I call the existential equation, the recognition that population change is understood really by looking at those factors that determine the regime of births and deaths, and the fact that the human evolutionary strategy, the human demographic strategy or life history strategy that allows for enough flexibility so that in the right circumstances births so vastly exceed deaths that our population size has exceeded 7 billion. In fact, it's a little bit over the 7.2 billion that I have in this slide, which is a mere year or so out of date. Another major theme for us during the quarter was to think about the nature of impact, and rather than having the simple conceptual model, what I know others have called the anti-Midas touch, the notion that everything that humans falls apart, we have been spending time asking questions about what aspects of environmental systems have the capacity to resist a certain amount of disturbance without changing their characteristic structure and function. We have been therefore using the language of resilience as a way of reconceptualizing impact. So now a relevant question for us is to think about how we can either utilize systems in a way that is not going to increase their fragility or reduce their resilience with a potentially catastrophic change, or else in those circumstances where we have to or feel obliged to or want to exploit an environmental system, how does one do it in a way that does not result in catastrophic change? One of the models related to this resilience worldview that we explored is this adaptive cycle model, which I had suggested to you does a couple of things. One, it extends the way in which the traditional model of ecological change, the traditional successional models, had at the beginning of the 20th century led us to a conclusion that in the absence of disturbance, ecosystems arrive at a climax condition which is fairly stable in perpetuity as long as there has not been a human disturbance imposed upon them. This model kind of not only extends the traditional model of succession, but it reminds us that disturbance is inherent in systems, and when viewed through the appropriate temporal lens, that all systems ultimately lose resilience, become vulnerable, and then potentially change. We summed it up a couple of days ago by looking at this general model that we have from Peter Wituszek and colleagues at Stanford, looking at kind of models of land transformation leading to the serious issues of climate change and biodiversity loss. Reading from top to bottom, in fact, we get a recapitulation of a lot of the work that we've done during the quarter. You need an understanding of human population change as a driver of environmental change, the way in which humans can, in this cognitively flexible way, institute a variety of kind of cultural enterprises, from agriculture to kind of recreational use in the environment, that results in land transformation, in transformations of global biogeochemical cycles, particularly of carbon, nitrogen, water, sulfur, and other key elements. Phosphorus we would maybe also add in as well. And the fact that we are kind of moving a lot of biota around the world and are responsible for the loss of a lot of biotic elements. And these things in combination result in some of the major environmental problems that we've talked about during the quarter, including climate change and loss of biodiversity. We concluded the quarter looking at some of the themes in E.O. Wilson's book, where he concludes in a way that even he concedes might be regarded as insane, although of course it may be regarded as brilliant and necessary, the strategy of setting aside half the earth in order to protect the remainder of life's biota. One of the sub-themes of Wilson's book, and one that we talked about in day one of the class, was what Wilson describes as the most dangerous worldview. And this is the view of kind of an extreme version of Anthropocenic thinking, which he characterized as being a view that since humanity has already changed the living world beyond repair, I'm quoting here, we must, they say, the extreme Anthropocenic thinkers say that we must adapt to life on a damaged planet, but in such a way that we evaluate the rights of other species on Earth in terms of their ability to furnish humans with a variety of ecosystem services. So the model would be, if you break it, I guess keep on breaking it, which is maybe not the way traditional conservation biologists have regarded these things. So very briskly we've reminded ourselves of a few of the themes out of several that bubbled up during the quarter. And this is your final assignment. I'd ask you just to kind of, in response to the assignment, just jot a word or two, a sentence or two in the comments section where you either identify an idea from the quarter's work that was completely new to you, things that you had not been invited to think about before, or perhaps an idea that wasn't new but it was reinforced in this class in a way that you found stimulating or provocative. Or finally, if there's an idea in this class that you might now want to apply to the other interests that you're pursuing. Thanks very much. I will see you soon.